Dr. Donovan, you had a question?
Don't call me that. Eric. Couple of points. Can you go back to your graph?
Yep.
It has the go back. There. Okay. The top graph is
surface temperature thermometer reading.
the bottom graph is
Sunspot number, global sunspot number.
Why does the peak in temperature lead the peak in solar activity?
That's a very good question.
The peak in temperature.
The peak in temperature happens about 20 years before the peak in solar activity. I'm curious why I would call that. I mean, that actually, if I was to look at that and to draw a causal conclusion, I would conclude erroneously that the temperature on Earth is controlling the sunspot number on the sun. Of course, it's nonsense.
Yeah.
So I think you have to be very, very, very careful with that graph.
Yeah, that's a good
because
point.
I don't think that graph says what you said it does.
Well,
in fact, I know that graph doesn't say what you say it does.
then what does it say?
It says that you have to be, honestly, that graph says you have to be very careful with time series.
Yep.
Okay?
Just move the graph.
No, come on.
I'm sorry. That graph says the peak in temperature led the peak in solar activity by at least 2 solar cycles. And that is the only, and then the next peak leads the peak. And the previous peak leads so the previous minima leads the minima. So I don't see how you can use that to conclude that the solar activity is controlling the temperature on the surface of the Earth.
That's a good point.
But isn't the very sharp peaks that we see on the lower graph, isn't that the solar sunspot activity, and the lower graph is that of the temperature?
No, the lower graph is solar activity. Mean solar number in the solar cycle, and I just think you should, and again you can go back as somebody said thousands of years, because China has detailed records of sunspot numbers going back thousands of years, right? And actually very accurate numbers, highly accurate numbers. And so I'm just curious, right? And the other point I would make is just from a marketability point of view, in a real scientific discussion, I think it's very, I would criticize you for not having uncertainties on the graphs that make your point, and having uncertainties on the graphs that don't make your point. And that to me is something that I would, because certainly those uncertainties for people who work in climate, which I don't, people who do work in climate, those uncertainties on the graph, the hockey stick graph, are standard uncertainties. And all the other records also have uncertainties.
Just one, I'll just throw one in here, is that this is just the 11-year cycle that's basically showing up on the Earth on temperature. There's about 4 other cycles that are superimposed on these, and then there's that are actually, and then in addition to that, there's no active cycles. So you basically have a fairly complex thing, and you're right in that this is it's not a straight 1-for-1 here, but the uncertainty is more likely to come from the result of the other superimposed cycles when they're analyzed than from any possible correlation with carbon dioxide.
I like those comments you made, actually. One of the things I didn't pick that out well enough myself, but I've seen a number of graphs of the smoothing of the cycle, whereby there is actually a very good phasing between the solar and the temperature. However, I think the other thing to be said is that I'm a guy that likes messy graphs, and anytime you do filtering and smoothing, you get into your question about how are you treating your data.
Yeah.
The second part, Steve, is that I have I think it's been published already, but there is an analysis that I have that shows the uncertainties for the sunspot part of the data. I don't pay as much attention to the temperatures because I'm trying to concentrate on the sunspot. So I do have a graph that not only gives the uncertainty estimates, because going back to the Maunder minimum, of course, that's way before modern instrumentation, so your proxy data you're a little bit worried about. And the other thing to worry about when you're doing uncertainties is it's heteroscedastic, so the variance is changing, and the phase of the sun is changing, so you don't even know what the phases of the sun really are. The third thing I'd point out is that that's a graph of sunspots. The graph that I have with the uncertainties on it also has it converted over with some approximations from solar physics, from the basis of sunspot numbers to total irradiance. But then that'll show a much more dramatic rise in the average levels with time as well, because that's sunspot numbers. It doesn't show you as well what the baseline on the energy is. And then the fourth thing is that total irradiance is only one measure of the sun's output. And I think that's one thing is we like to relate to simple measurement, and a lot of times with the sun, that gets you in a lot of trouble because there's a lot of facets to the solar output. So I can provide that to you, Steve.
Thank you. I just thought maybe I could explain this last graph here. This is the sunspot number here, global sunspot number, and this is also, the green is beryllium 10 in Greenland ice, and red is beryllium 10 in Antarctica, actually. And then also this blue one is carbon 14. So it also acts as a solar activity proxy, but there's a lag associated with it as well. So a lag of looks like about 100 years. On the order of 100 years.
Well, thank you. Can I ask one more question? Sure. If that lets me ask one more. You're really interested in the galactic ray side of things.
Yeah.
And you didn't really get into this side of things, but you've been focusing on that. And that's Tim Patterson brought that out. And that's really quite exciting. It's still well under development. Maybe there will be a lot of surprises, but you're interested in the very long term, galactic ray side.
Yeah, but I thought maybe I could just start with your
Thank you very much, Steve. It was a very enlightening presentation, and we found it quite encouraging. And so everyone give a round of applause.